Hello and welcome. In this video, we're going to go through Form 4 Additional Mathematics Kssm textbook question, Chapter 2 Quadratic Function Intensive Practice 2.3. Hi, my name is Terry. If you like this video, please click like, and if you want to receive more notification from us when we upload a new video, so please click subscribe, and always give comment if you think certain things that you don't understand, you need me to clarify. You can just comment, or any way we can improve our video, please do let us know. So let's get right to it. Now, the first question, we are finding the range of values of k given that the quadratic function has only one intercept. To be exact, it's supposed to be one x-intercept, because your quadratic function may intersect the y-axis. No matter how you draw, actually it will intersect the y-axis, but it can only have either one x-intercept, two x-intercept, or no x-intercept, something like this, right? So in this case, we know our a is k, b is -4, c is k minus 3. If it has only one x-intercept, we know it's going to have only one real root. Yeah, so our b squared minus 4ac value should be 0. So let us substitute b, square it for a is k, c is k minus 3. I'm going to let this be 0. -4 squared is 16. 4k times k is 4k squared. -4 times -3 is positive 12k equal 0. For me, I will just divide by -4, yeah, to make the equation smaller. 12 divided by -4 is -3, and 16 divided by -4 is -4. So if the number is small, it's easier for us to factorize. So the factor here will be 4 and 1, minus and plus. So my k is -1 or 4. Okay, part B, my a is 3, my b is -4, and my c is -2, 2k plus 4. So as you can see, it intersects the x-axis at two different points. So it's this case over here, you are going to have two real roots. So my b squared minus 4ac value is going to be more than 0. So when I sub inside, my b is -4, again square it, 4, a is 3, c is -2 with 2k plus 4 more than 0. This is 16. Okay, this will be positive 24, right? Let me multiply one by one. Actually, you can divide everybody by 16. Yeah, but if you cannot see it, it's okay. I'll just do the long way. Yeah, because all these numbers are divisible by 16. So 48k plus 112 more than 0. 48k is more than -112. 112 divided by 48 is -7 over 3. So I think this is not that difficult, right? Yep. Okay, question number 2. Find the smallest value of integer m such that this equation, this quadratic function actually, is always positive. So now we know a graph is always positive if the entire graph lies above the x-axis. You can see all your y value here are positive. For example, this is 0, 1, 2, 3, 4, 5. All your y value is more than 0. So if that happens, there are actually two conditions. Number one, your a must be more than 0. It only happens for smiley face graph. Yeah, your positive coefficient of x squared. Number two, if your real root you should have no real root, right? So it doesn't cut the x-axis. When you cut the x-axis 2 points, you have two real root. It touches x-axis 1 point, you have one real root. In this case, it does not intersect. So we are going to do b. Okay, by the way, my a is m, my b is 7, my c is 3. So I'm going to use b squared, which is 7 squared, minus 4. A is m, c is 3. And this is less than 0. 7 squared is 49. This is minus 12m less than 0. Minus 12m less than minus 49. Every time you times and divide negative, please change the symbol. Now for me, I would like to write in mixed number for 1 over 12. So I can see clearly that the smallest integer value of m should be what? If m is more than 4, 1 over 12, sorry, m should be just 5. Alright, so moving on to question number 3. Okay, so here we have to complete the square. So for me, the way I complete the square is that I like to use this method. Let me explain it quickly. X squared plus bx plus q. Now p can be anything. We take half of p, which is p over 2. You square it, and then you minus it out, keep the q, right? So in this question, my p is 6. Half of p will be just 3, and then you square it. But you must always minus the 3 squared. 3 squared is 9. I know you'll be thinking, why? Why do I minus 9? Because if you were to expand this, right, you should get an additional term of 3 squared, which is 9, right? So this 9 here, we need to minus it off, right? So that you will get back the same thing as above here, right? You want to get the same thing here. Can you see that? Right? So that's why we always minus the additional term that we have created, which is your coefficient b, coefficient x, which is b, half it, you square it, right? So you got to minus it off. Okay, so I'm just going to delete this. Yeah, I don't want to. Don't have to expand it, because if you expand it, you're getting back to where you started here. We don't want that. Yeah, we want to complete the square. So actually, I'm done for part A. I've completed the square already. But the next part is, they say the minimum is -5. So we know, we can read from here, your fx has a minimum value of -9 plus n, right? Remember, the one outside the bracket is your minimum or your maximum, provided your a is more than 0. And we can see that your a, in this case, is more than 0, so it's a minimum. And this minimum value is -5. Yeah, -5. So -9 plus n, n is now 4. All right, the next thing, part C, we have to sketch a curve. Before you sketch a curve, always identify the minimum, maximum. Now, maybe we can just rewrite this so I know the minimum is -5, right? My fx minimum is -5 when x equals to -3. So -3 is my axis of symmetry. So let me just draw somewhere here. -3, yeah, -5, perhaps a bit lower. Okay, so this is my minimum point. Correct. So everything else must fall above. So let's just draw a nice looking sketch. Okay, it's not so nice looking. So maybe I should reverse the order. Yeah, when I say reverse the order, I personally find it's easier to draw this curve first, right? As in, you draw a nice looking curve, freehand. Oops, not very nice looking. Okay lah, it's not too bad. So I draw my intercept, right? And this is -3, -5. Yeah, because if you try to draw all the value first, right, you try to fix the position, it's actually harder for your hand. You need to make sure that it goes through that particular point. So just draw a freehand first, yeah, and then I'll just add in the axis later. So you notice in this case, it will cut the x-axis and the y-axis. Now we know at x-axis, your y is 0. Right, so we're going to take x plus 3 squared minus 5, let it be 0, bring the 5 over. Whenever you square it, please put a plus minus, and your x is -3 plus minus root 5. So the one that is minus I put on the left hand side, as you can see here. The one that is plus I put on the right hand side. So we can just leave it in the form of root, don't have to change to decimal. In fact, I think the textbook doesn't show the x-intercept, but by right, whenever you draw a graph, we need to show the x-intercept and y-intercept. Now, y-axis, x is what? X is 0. We are going to put 0 inside here. I think it's better to put inside here, right? Your fx is x squared plus 6x plus n. What's my n? My n is 4. So when I put x equals to 0, my y is just 4. Well, this is 4. And my graph is complete. Okay? So that is number 3. Let's move on to number 4. Find a range of values of r such that this straight line y equals to rx plus 4 does not intersect the curve. Okay, now I know I have to solve them simultaneously. Equation 1, equation 2. So when I sub 1 in 2, my rx plus 4 is now x squared minus 4x plus 5. Let us rearrange it. Minus 4x minus rx plus 1 is now 0. We want to factorize this, and we can do b squared minus 4ac less than 0. Why less than 0? Does not intersect. If you try to solve them, you shouldn't have any solution. Should not have any real root. Yeah. So my a, okay, I hope you know your ABC, right? My b is -4 plus r. I square it. My a is 1 and my c is also 1. This is less than 0. Now here I have two ways of solving. One is by sketching the graph. One is by using the shortcut. square root both sides. Now, negative 1 here, there's a negative 1 here, that when you square it, what happened to the negative 1? It becomes positive, right? So this is still 4 plus r. And then you square it, minus 4 less than 0. Now remember, a squared minus b squared is what? A plus b, a minus b. Now I personally like to do this. I don't like to expand and factorize because I'm doing double work. So when you do 4 plus r, this will be a plus 2 because your b squared is 4, b should be 2, and 4 plus r minus 2 less than 0. In this case, r plus 6 and r plus 2 is now less than 0. And normally, when you want to solve quadratic inequality, we sketch a graph. The roots are minus 6 and minus 2. Less than 0 means the region should be below here. Your r will be between minus 2 and minus 6. Now, oh, sorry, I need to show you the second method. Now, the second method is this. We are going to bring, this is, by the way, method 1. This is method 2. I'm just going to bring the 4 over. Yeah, we can square root both sides. So when you square root both sides, you need to plus minus the negative 1 and the positive 1. The negative 1, we change the symbol. The positive 1, we maintain the symbol. So r is now less than negative 6. R is less than negative 2. Now, this may appear to be much easier, but just remember to always change the sign for the negative 1. Always change the sign for the negative 1. All right, and we can actually combine this. If r is more than minus 6, right, but less than minus 2, we can actually combine them and write this as the answer. Okay, but we're not done yet because there's a second part to this. State the value of r such that y equals rx plus 4 is a tangent to the curve. It's the same curve, same equation, but now it's a tangent. Very simple. When it's a tangent, how many roots do you have? 1, right? So your b squared minus 4ac should be what? Equals 0. And if you solve this, right, you can see when your b squared minus 4ac, we just take this equation, you let it be 0. Your r will be just what? Negative 6 and negative 2. You don't have to do further working because it's just the same. You're just using the result from the first part. Okay. All right, let's move on to number 5. Okay, in question number 5 is more descriptive. You don't have to calculate so much. You have to more of explanation, explaining why the changes on the shape and position of the graph. Okay, so generally, if I write fx is a bracket x minus b squared plus q. You may see this in different form. This is called the vertex form. I think the text will use h and k. Here I use b and q. Doesn't matter. They're all the same. So now a affects the shape of the graph. If your a is bigger, it would be narrower, right? If your a is, the magnitude of a is more than 1, so it's narrower. If your magnitude a is less than 1, it's actually broader. But normally we use the term the width increases or the width decreases. So for part A, you can see what happened to my A. My A actually changes from 3 to 6, right? So my A actually gets bigger. So if I were to sketch this graph, by the way, just a sketch will do. Your minimum is at 2 when your axis of symmetry is at 1. So the original graph looks something like this, right? This is the case where your fx is what? Or your y is 3. Okay, now the moment you increase it to 6, the graph actually goes higher like this, right? So it's actually narrower, right? Or we say the width decreases. So what can we write here? Yeah, we say the width of the graph decreases. Okay, what else? Your axis of symmetry and your minimum value doesn't change. It's still at 2. Yeah, your axis of symmetry is still at 1. So we say axis of symmetry and the minimum value, or the vertex if you like, remains unchanged. Okay? Alright, that's only part A. Part B, let's look at the changes in your graph. So it's actually the same graph, but now your axis of symmetry, so let's just focus on this here, axis of symmetry here, it changes from 1 to 4, right? So, okay, I just draw another graph for you. Same graph here, same shape, this is 1, this is 2. Now the graph will move, okay, to 4. So here, right, this is now 4. So your x value, yeah, is shifted to the right, right? Can you see? Or your x value is shifted to the right. So we say your p value before this is -1, it goes to -4. Okay, I'll just write like this. So the width of the graph remains, the shape remains unchanged, right? Okay, so the shape and so shape of the graph and the minimum value remains unchanged. However, what happened to your axis of symmetry? Axis of symmetry, yeah, is shifted to the right by 3. From 1 to 4 is 3, right? Yeah, to x equals to 4. Okay, now you can use your own words. That doesn't have to be exactly the same as mine or exactly the same as your answer at the back. Okay, so how about C? Let's look at C. What actually changes from 2 to 5? So my minimum now goes from 2 to 5. Everything else the same, right? So you can say the Q value. I say Q value here, change from 2 to 5. So let me do a sketch. Perhaps I do the sketch in the middle and I do the explanation below. So before this, my minimum is 2, right? So I draw the same thing. Now my minimum is at 5, so it goes a little bit higher, right? The width is the same, so maybe yeah, looks more like the same thing. So this is 5 over here. All right, so we say width and, okay, should I say the shape of the graph? The shape of the graph and the minimum value, sorry, not minimum value, axis of symmetry. Axis of symmetry remains unchanged, and however the minimum, should I say the graph is shifted up? Yeah, the graph is shifted up by 3. Yeah, from 2 to 5 the change is 3 to minimum value of 5. Yeah, or should I say the minimum value is now increased to 5. All right, moving on to the next one, question number 6. So here we have height in meter of a bird to catch a fish in a pond. Can be represented by this function, ht equals to 2 bracket t minus 3 square. T is time second. When the bird starts to fly to catch a fish, sketch the graph of ht. So I think when you sketch a graph, we can see from here ht is 2t minus 3 square. So your a is more than 0. Your ht has a minimum value of 0 when t is 3. So the graph should go like this. Okay, this is my x-intercept and y-intercept. So originally your minimum is 3. Now we can also find your y-axis, intersection with y-axis. So we know y-axis happen when x is 0. In this case, t equals 0. So I'm going to put t equals 0 inside. I get 2, 0 minus 3 square. This is now 18, right? So my graph looks like that. Okay, so I've done my graph of y equals to ht. So then B, they say the movement of another bird is represented by the function rt equals 2 times of ht. Now when it's 2 times of ht, that means my a value is now double, right? So you can say rt is now 2 times of ht, which is 2t minus 3 square. This is 4t minus 3 square. My a is now double, so the graph is now sharper. So you have to draw another graph, but this time you can see is sharper. Maybe I draw here. Now I'm actually magnifying this. It's a lot higher here. This is your y. Your axis of symmetry remains at 3, but we again have to put 0 inside. This is now 4, right? 0 minus 3 squared is going to be 36. Yeah, it's a lot higher here. 36. Looks a bit ugly. Let me fix this. Okay, the next thing is compare the graph. Which bird? This is y equals to rt. Yeah, y equals rt. Which bird start to move at a higher position? Explain. By the way, I keep writing this as x. This is t. Yeah? So we say when you compare the graph, right, we can say the graph of HD has the width of the graph of HD is bigger. Yeah, bigger width. Yeah, is greater than the graph of RT. You can also mention the graph of HD is wider, just use the word wider, or you can say the graph of RT is narrower. Yeah, you can use that term. Okay, but how do you compare which birds start to move at a higher position? We know when they start to move, T is 0, right? When T is 0, your H0 is 18, your R0 is 36, right, in meter. So we say the bird represented by the graph y equals to RT. RT here moves, or should I say start to move at the highest, yeah, at 836 meter as compare, which is higher, maybe I write here, which is higher compare to the bird represented by y equals to HD that starts to move at 18 meter. Okay, I think that is good enough. Okay, so let's move on to number 7. Yeah, we still got a couple more. Right, find, given a quadratic function, right, this is always negative. The graph is always negative when your b squared minus 4ac is less than 0. Again, I hope you know this. Your a must be less than 0. Your b squared minus 4ac is less than 0 because it has no real root. But perhaps I should rearrange this first so that you can see what's your a, b, and c. Yeah, my a is -1. This is my a. This is my b. This is my c. So my b squared minus 4ac is less than 0. Negative k plus 3. When I square it, 4ac less than 0. Expand this, k squared plus 6k plus 9. Now what happened to the -1? When you square it, it's now positive, so you don't have to bother. Then this is positive 12, then minus 16k less than 0. We can simplify this, k squared minus 10k plus 21 less than 0. Double bracket factorize this. 7 and 3, they are both negative. For quadratic inequality, we sketch a graph. The roots are between 3 and 7. So less than 0, the region should be below here. Move it up, and we can say k is between 3 and 7. Therefore, let's compare. Yeah, p is your k value between, p is your minimum value, so p is 3. Q is your maximum value, so q is 7. Alright, moving on to question number 8. Diagram shows a bridge with a length of 8 meter. Alright, so you're supposed to find out the value of B. Okay, if you look at the diagram here, right, now your B value, we need to complete the square and compare to find the B value, right? So maybe I start off by taking out 1 over 8, so this is x squared. B, if you divide by 1 over 8, actually is the same as multiplying with 8. So I'm just going to leave this out. Alright, and I'm going to take half of 8b, which is 4b. Yeah, half of 8b is 4b, and when you square it, is minus 16b squared. Keep the c outside. The 1 over 8 we can multiply inside, right? And from here, this is negative 2b squared plus c. Okay, let's compare our axis of symmetry. You can see if the width here is 8, right? Your middle line here should be x equals to 4. So my axis of symmetry is actually 4. Now I know my maximum value. Okay, maybe I say my minimum value here is minus 2b squared plus c. It only happens when the one inside the bracket is 0, x is negative 4b. So by comparing my axis of symmetry from the graph, which is 4, with the axis of symmetry from the equation, which is negative 4b, I got b to be negative 1. Now they say find a value of c such that the minimum point B on the cable is always above PQ. Now if it's always above PQ, right, your minimum value here must always be more than 0. So since I know B is negative 1, so I'm going to put negative 1 here. I square it plus C more than 0. Minus 2 plus C is more than 0. C is always more than 2. But part C, they say find the value of C if B is 2 meter above PQ. If it's 2 meter above PQ, that means your minimum value is 2. So now let's take our minimum value, which is actually we can just use this result, right? Because this is the same thing. This is your minimum value, right? Minus 2 plus C is now exactly 2. So my C is just 4. Okay, that's number 8. Let's look at number 9. Function ht equals negative 4t squared plus 32t. Yeah, we are supposed to find when did it explode. Okay, so we have to complete the square obviously, so we can start off by taking out negative 4 t squared. 32 divided by negative 4 is negative 8. Alright, so we can take half of 8, which is 4, square it, 16, and then you minus multiply the negative 4 inside, so it's 64. So when did it explode? We know it has a maximum point of 64. We know it's maximum because your A is less than 0. And that happens when the one inside the bracket is 0, T is 4. So when it explodes? After 4 seconds, because this unit is in second, T second. Alright, so what is the height when it explodes? Oh, maximum height. I've got the answer as well. Maximum height is 64 meters. Alright, so that's your part A, part B. Now, I know some people may find a completing square is a bit annoying, so you can actually draw a graph, right? We let this be 0. Okay, I'm just going to show you a quick one. This is the, let it be 0. We take out negative 4 and t, so this is t minus 8 equals 0. So the roots are 0 and 8. You've done this in your normal maths, right? That your A is more than 0, sorry, less than 0, so it's a maximum graph, and the roots are just 0 and 8. Okay, so we know their axis of symmetry. Very easy, you can find it by taking 0 plus 8 divided by 2, you get 4. So the time where they explode is t equals to 4. And to find the maximum height, we know it happens when t is 4, so we just put, oh, I still cannot undo this. We just put 4 inside here. This will be negative 4 square, negative 4t squared, t is 4, negative 4t squared plus 32t, you will still get 64 meters. Alright, so I'm just giving option, you can use another way to solve it. Alright, next one, question number 10, sorry. Now, this is a graph of a quadratic function in factor form or factorized form, or sometimes the text will call it intercept form. So, given that m is the midpoint, yeah, express the following. Okay, I think it's very easy. We know this is alpha, this is beta. They say alpha is less than beta. So your midpoint x, you're finding the length of OA. So first OA is just alpha, then OB is just beta. Can you interpret alpha plus beta over 2? Now we know it's your alpha plus beta over 2 is the axis of symmetry, isn't it? Yeah. Okay. And how about negative alpha beta? Now you know if you substitute x with 0, this is negative 0 minus alpha, 0 minus beta. This is negative alpha beta. So what does this thing represent? The negative alpha beta is the y-intercept of the curve. All right. Next one, number 11. Now the maximum value of this function is m squared plus 2n. Okay, so I think we have to complete the square. So we take half of negative 4, which is minus 2n. There's a negative 4n, so half of it is negative 2n. You square it. Negative 2n, if you square it, is 4n squared. Now always remember, you always put a negative outside, no matter what. Regardless whether this value is positive or negative, you always have to minus because you're subtracting the additional term. Alright, so this will be just n squared plus 1. So we can see that this is my minimum value. So my minimum value is now n squared plus 1. And we can compare. My minimum value given here is m squared plus 2n, and is now n squared plus 1. We're supposed to find m. M squared is now n squared minus 2n plus 1. As we can factorize them, right? If you square root it, Malaysia, m is just n minus 1. Alright, that's the end of this chapter, this discussion. So if you like what you see, you know, my explanation, and you think you want more additional practice, we have lots of learning modules that comes with video solution, alright, that can actually help you to enhance your understanding and your knowledge on this additional mathematics. And we also have tuition classes, right? So do get in touch with us if you want to find out more, yeah, from our website, our WhatsApp, or even call us, right? Thank you very much for watching. I hope you learned a lot from this video. I'll see you in the next video.